Hello, welcome to Science with Mrs. Blackburn. As you can see today, we are back in the kitchen. As we work through our unit on matter, we're going to be cooking up some special things. Today we are going to make some cinnamon Christmas hard candy. And the reason we're going to do that is because we need to know a little bit about the phases of matter, or the change in the states of matter, in order to make that recipe. So before we start cooking, let's look a little bit into how matter can change from one phase to another.
So matter can exist in various states or phases, and that's what we're going to talk about today. So the first state or phase of matter that I want to talk about is a solid. Now a solid has a few characteristics. It's going to have a definite shape to it. The particles in a solid are going to be closer together, so the atoms or molecules inside of that solid are going to be kind of tightly packed together, and that's what will give it its definite shape. And we actually have two main types of solids. We have a crystalline solid, and that is where all of the particles are nice and neatly stacked together. They're in a very ordered pattern. Good examples of crystalline solids are things like salt, and you see the little salt crystals from that, and even our gemstones and diamonds, things like that would be crystalline solids because their particles are very nice and orderly. Now the opposite of that would be an amorphous solid. Anytime you see the word morph, that means form, and if you see the letter A in front of our word in science, that means like the opposite of or not. So an amorphous solid means it doesn't have the particles aren't orderly. They are tightly packed, but they're not going to be in an orderly fashion. They don't have a particular form to them. So a lot of our foods are examples of amorphous solids. Things like chocolate, cotton candy, things like that would have particles that are tightly packed, but they're not going to be in a very ordered pattern. So something that we need to know is that all particles tend to move around and vibrate. Okay, they're always moving, and they are so tiny, and in solids they're going to be moving all the time, but we can't necessarily feel it. Like, you don't feel all your little particles moving right now, okay? But when we add energy to the system, okay, if you add energy to a solid, let's say like thermal energy, those particles will start to vibrate more and more and more, okay? Because that thermal energy or heat will be transferred to the particles, and it's going to make them shake even more. And if you add enough thermal energy, and if these particles shake and vibrate enough, they are going to kind of loosen up, and they will reach what is called their melting point. So for every material out there, it's going to have a melting point. There's going to be a certain temperature, and it will be consistent for whatever material you're talking about, okay? That at that temperature, the particles in the solid state, if you get them to that temperature, they will vibrate enough to where they'll kind of loosen from each other and go from a solid to a liquid. That's called the melting point. So, for example, the melting point of water is about 100 degrees Celsius, okay? And that's just what it is for water. If you get water from your sink or water from, somewhere else, rainwater, it's going to have the same melting point. It is consistent across substances, okay? So that is the melting point, and it will be different for different materials, because different materials, as we talked about last week, are going to be made of different atoms and molecules, and they'll be organized in a different way. So the melting point is the temperature at which a solid will melt into a liquid. So here's the thing about a liquid. A liquid is going to have a definite volume, okay, but no definite shape. That means it will kind of assume the shape of what you pour it into. The molecules will slide past each other. They're more loosely packed than in a solid. And so, for example, if you have a cup of water and you pour it into a glass that shapes differently, it will take on that shape because those molecules are going to just slide past each other. So What happens if we add more thermal energy or more heat to a liquid? Well, the same thing is going to happen. They're going to keep vibrating and moving more and more until they evaporate. Evaporation is the phase change from a liquid to a gas. So that is called, the boiling point is going to be the temperature at which the molecules go from a liquid to a gas. Now, a gas is not going to have a definite shape or volume. Either one, it will take the entire shape of its container. That's why you can blow up a balloon, because the molecules in that balloon, the air that you just blew into the balloon, will be in the gaseous state, and all of those molecules in there are going to bounce back and forth and assume the shape of that balloon. So the boiling point is going to be that particular temperature in a substance at which a liquid of that substance will change to a gas. So just like melting point, boiling point is going to be consistent for whatever substance you're talking about. Okay? Now that we've talked about what happens when temperature increases, okay, we go from a solid to a liquid to a gas. Let's talk about what happens when temperature decreases. So let's say that we remove thermal energy from a system. So how could we do that? It's as simple as putting maybe some water in an ice cube tray and putting that in your freezer. You are taking the temperature down. You're removing thermal energy from that system. And what's going to happen is it's going to be the opposite of what happens when you heat something up. So let's say we have a gas and we lower the temperature of that gas. What's going to happen is the molecules are going to kind of calm down. They're still going to be moving, but as they calm down, they'll kind of bunch up and lose energy and close in together into a liquid state. That's called condensation, when something goes from a gas to a liquid. You see that, for example, when you get out of the shower and all that steam from your shower collects on the cool glass of your mirror, and then you see water running down that mirror, or it fogs up. Okay, that's condensation. That's going from a gas to a liquid. And so if this happens even more, if we take the temperature down, we will eventually reach what we call the freezing point. That's going to be the temperature at which a liquid will freeze into a solid. And those molecules will lose energy. They will move closer and closer and closer again until they are the solid state. So that freezing point, okay, is actually going to be the same as the melting point, because when you think about it, that's just a couple of degrees where you can have, for example, if we're talking about water, you can have either ice or water, liquid, water, or solid ice. So that freezing point is where a liquid's going to freeze into a solid. Now, there are some weird phase changes out there. So you've probably heard of all of those other ones, and we just needed to talk about what was going on with the particles. But let's talk about some weird phase changes really quickly. So there's something called sublimation. That is when a solid goes directly to a gas. Now, we're not very often in a situation where there's enough of an energy change to see this, but you do see it with certain things around. So one of the best examples of sublimation, going from a solid to a gas, is dry ice. Dry ice is just the solid form of carbon dioxide. Now, you know that carbon dioxide is a gas that exists naturally in our atmosphere. We breathe it out, plants take it in, and so at just room regular temperature, it's going to be in the gaseous state. For it to be a solid, it has to be very, very, very cold, okay? So it is cooled down really, really, really cold, and people can purchase it to keep certain food items cold, or sometimes people use it for decoration or effect, because when that solid carbon dioxide is exposed to room temperature, it directly goes to a gas state. You're not going to see the liquid form, because it's basically going to start, quote unquote, boiling or evaporating on contact with the air. And so that's really, really neat. Now, the opposite of that is called deposition. Deposition is when we go from the gaseous state to a solid state, and this is actually a little bit more common than you would think. When you go outside, especially this time of year, when you go outside in the morning and there's frost all over your car and all over the grass and the trees and everything, that is because some of the evaporated water, the water that's in the gaseous state in our atmosphere, will actually go straight to solid frost once it freezes outside. So going straight from a gas to a solid is going to be deposition. So before we start cooking with our knowledge about phase changes, let's look at this graph very quickly together. So this graph just shows that when heat energy and temperature increase, we go from solid to a liquid to a gas with different materials. And the reason why is because when thermal energy, heat energy, is applied to a material, the particles in that material are going to start vibrating and moving more and more and more and more until they start moving apart from one another. And like we said earlier, in a solid state, the molecules will be packed tightly together. In a liquid, they're a little bit more loose. And then in a gas, they're just kind of bouncing everywhere. So this phase change diagram just kind of shows us what happens. It also has little arrows that show us the direction of melting and freezing. So if we take this diagram and look at what is going on when we lower the temperature, we see that you have things like condensation and freezing as temperatures lower, and melting and evaporation as temperatures rise. So this is pretty cool. Let's use this information to cook something.
Before we begin, it's really important to know that to make this candy, we have to use really high temperatures and sugar, which is going to come to a boil. So it is not something that you want to try to make on your own at home, okay? If you do want to try this recipe, make sure that you have a parent or a grown-up with you to help you work with some of the hot things, okay? Because melted sugar on your skin is not a good feeling. So make sure that you don't try this at home alone. This recipe only requires a few simple ingredients. You're gonna need some just plain regular sugar. You'll need some light corn syrup, some powdered sugar, some cinnamon oil flavoring for candy, and you'll need your choice of food coloring. I've chosen green for this one. And finally, you will need a special candy thermometer because it's going to be important that we get things to the right temperature for this. Finally, to put everything in, you will need a nice sized cooking pot. And then for our candy at the very last part where we pour it in, you're going to line a cookie sheet with aluminum foil and put a lot of butter on it. So I've lined this with butter so our candy won't stick. So I have actually pre-measured my ingredients just to make filming a little bit easier. But the way you start this recipe is you're going to measure out 2 cups of plain sugar. You're going to measure out 2/3 of a cup of your corn syrup. And you're going to measure out 1 cup of just plain water. And what you'll do first is we're going to pour our water into our big saucepan. And then we are going to add our sugar. And I haven't started heating this yet. And then finally we are going to add all of our corn syrup in there. And I'm going to use a whisk to give this a nice stir and mix all of these ingredients together. And just a little throwback to the last video, we're actually forming a solution here. We're trying to dissolve the corn syrup and the sugar in this water. And then once we have it nice and mixed together, and it'll be kind of a thick mixture. It's taking me a minute to get all this mixed into a nice homogeneous mixture. Once I have done that, I'm going to turn on my heat to kind of medium-high and wait for this solution to start boiling. As we wait for our mixture to boil, I want to talk to you a little bit about the thermometer that I'm going to use. So this is just a special candy thermometer. And as you can see in there, we have two sets of numbers. Today I'm going to use the Fahrenheit side. And what we're going to try to do is see right here the 300 degrees Fahrenheit, which is about 150 degrees Celsius. The 300 degrees Fahrenheit, right where my thumb is there, is where we want our mixture to get before we take it off of the burner and pour it into our cookie sheet. Now, the reason for this is because that is the temperature at which pretty much all of the water from this solution is going to evaporate out of the candy, okay? So remember when we talked about states of matter a little while ago, we said that that evaporation is when a mixture, or not a mixture, but any substance goes from a liquid to a gas. And the point of this type of candy making is we want to try to get all of the water molecules to evaporate out of our mixture, and that's going to give us the texture of the candy that we really want. Now, the boiling point of water is about 100 degrees Celsius, okay? 100 degrees Celsius, which is about 212 degrees Fahrenheit. Now, if you'll notice, 300 degrees Fahrenheit, or 150 degrees Celsius, is way higher than that. And that's for us to ensure that we get all those molecules, those water molecules, out of our mixture. In baking, this is called the hard crack stage. It's where you try to get all the water out of your candy. Now, some other types of candy, and all candy is just basically boiled sugar, other types of candy might be boiled to a lower temperature because you want some of that moisture still in there. But for what we are doing, a hard candy, we want it to be at 300 degrees Celsius, that hard crack, or 300 degrees Fahrenheit, that hard crack stage. Something that I'm noticing as we are inching closer and closer to that 300 degrees Fahrenheit mark is that the consistency of this solution is changing. As you notice, it's bubbling a little more slowly, and it's getting a little bit more gooey, for lack of a better word, getting more of that candy consistency. And so that's where I know that we are getting closer and closer to all of the water molecules being evaporated out of this solution. We are now at 300 degrees Fahrenheit, so it's time to take this off the burner and add our cinnamon oil and food coloring. So now I'm going to add a teaspoon of cinnamon oil very carefully. Now, you don't want to do any more than that because a little will go a long way. And the same thing with just a few drops of the coloring. Just a couple, there we go. That might even be too much. So I'm gonna mix all of this together really nicely. Oh guys, my house smells like cinnamon. It smells so good. You wanna keep your face away from all of this evaporation going on here because some of that cinnamon oil coming out, and whew, it'll burn your eyes if you don't watch out, but it sure makes the house smell nice and yummy. So we'll mix that together really well, and I can tell, as you can see the consistency, how that changed. We've evaporated pretty much all of the water out of this mixture. So, funny story. I went to put the camera down and pour our mixture into my baking sheet, and I realized that I picked way too big of a baking sheet. So we basically have a puddle of our candy mixture in the middle. It's still gonna work. It's just not gonna look as pretty as I thought it would. So it's really funny here. Take a look. Here is our puddle of candy, and all we have to do now is wait for it to cool. I should have chosen a slightly smaller cookie sheet, but no worries, we're gonna break all this up here in a little bit. But something I did wanna show you as we're talking about the phases of matter. So this was a liquid pourable solution, And as I poured it out, it started pouring more slowly and more slowly, because as soon as I took it off the burner, it began to freeze back. And I know when we think of freezing, we use it in terms of the freezing of water, okay? So you think that something that is freezing should be cold, but actually this mixture started to freeze. In our scientific definition, it went from a liquid state to a solid state really quickly, even so quickly that as I poured it out, you can see these little, they look like little whiskers or strings on my whisk here, okay? You see that they froze before it could come off of my whisk, and I think that's neat. And even on this side of the pot, this looks like liquid. This is solid candy now. So as you can see, the freezing point or melting point, which is the same as we talked about earlier, is going to be not too high, or not too low, I mean, for this material now. So all we have to do now is wait for our candy to cool, and then we can try it. You all are probably gonna hate me for this, but it has whiskers. So our nice little puddle of goo, our cinnamon candy solution, has finally cooled, and it is now in the solid state, which means all of its particles have kind of calmed down now that we took that thermal energy away. And they move closer and closer together to where now we have a definite shape, a definite volume, okay? Even though it still kind of looks like it's liquid, it froze as soon as I put it on the pan. Now remember, when I say it froze, does that mean 32 degrees Fahrenheit like water? No, it can be a higher temperature for other materials like this solution that we have here. So the last step with this recipe is the most fun part. We have to break this into pieces, okay? So you could do this in a variety of different ways. You can use a butter knife, or even a little hammer, or a meat tenderizer, something like that. But I've just got this nice old-fashioned wooden spoon, and I'm just going to give it a few cracks so I can break this into some pieces. So now I've broken up all of my candies, and as you can see, they look really pretty and shiny, almost look like broken glass, but this is candy. And look how pretty that is. One last step we can take is to add some powdered sugar. So what I have is I went ahead and put my candies into just a little bowl that has a lid, and I'm going to add some powdered sugar to it. I put the lid on the bowl, and now we get to do something else that's a fun part. We get to shake it. And look at that. Look how nice and yummy that looks. That makes the perfect finishing touch for our Christmas cinnamon candy. So here's my favorite part of the whole cooking process. I get to taste it. Look how yummy this looks. So let's taste one of our cinnamon candies. I'm gonna pick a little one. Oh, that's so good. It just tastes like Christmas. So cinnamony and sweet, and we did a really good job today. So let's review a little bit about what we've learned today. We've talked about how matter can change phases or change states from solid, liquid to gas through processes like evaporation and condensation and melting and freezing. We've talked about how different materials have different boiling points and freezing points. And we use some of this know-how to help us make a tasty treat in the kitchen. So I hope that you enjoyed this time, and thank you so much for watching. Have a very Merry Christmas.